Hello there. In this video lecture, we are trying to learn how to draw the free body diagram. So here, one problem I have taken, the two equal loads of 2500 newtons are supported by a flexible string A, B, C, D, the name of the string at the different positions at points B and C. So the loads 2500 newtons loads are acting at the point B as well as the C. Find the tensions in the portions of AB, BC and CD of the string. So there we can see the string A has taken one end of the string, that is connected to the left side vertical wall at A, and the string is called AB, which is making 30 degrees to the vertical plane. And similarly at the point B, there is a connected another string, that is the BC. At the point B, it is going to be making 2500 newtons vertically downward direction, and it is also making with the vertical axis that's going to be 120 degrees. At the point C, there is another string is connected to that is the CD to the left side vertical wall. At the same time, the C is subjected to 2500 newtons, and it is going to be making the BC string at C with the vertical plane is making 60 degrees. At the point D, the CD string is making 60 degrees to the vertical wall. So these are the conditions he has given. So we need to draw the free body diagram. So as we know that the free body diagrams, we need to remove all the supports, and then we need to consider by providing the reaction forces, and then we are considering the equations of equilibrium. That means each point is going to be considered as an equilibrium point at A, B, C and the D points consist of equilibrium conditions. Then only the system is going to be at the rest condition, we can assume. So here the free body diagram I am trying here. By taking here the free body diagram I am taking at the 2 points. If I am going to be taking at A and the D, only the two forces are there which are the unknown parameters. That's why I am going to be taking the free body diagrams at point B as well as simultaneously at the point C, so that I can calculate the different values. So here the equations of equilibrium at a point B. So there first I have considered that a point B, and then I am going to be taking the tensions in the AB as well as the BC, and the inclinations I am going to be mentioned here. So first one is going to be the tension that's going to be called, that is the tension existed in the AB. That's the arrowhead is moving in that direction because it is making with the vertical axis is going to be the 30 degrees. At the same time, the tension I have shown here is the T1. And this is also making with the vertical is going to be the 30 degrees. And the load is acting here already given 2500 newtons. And the next I have taken the tension in the BC string that is going to be acting towards the left side, towards the right side downward direction, and it is also tension is called the T2 and making 120 degrees. Then with this one the system is going to be considered at the equilibrium at the point B. In the next case I am going to be taking the equations of equilibrium at point C. So in this case also the three forces are going to be there, then two unknowns are going to be there. So then first I am going to be considered the point C. The next, the tension already that is existed in the BC string is going to be the T2. It is going to be making an angle with the vertical axis is going to be the 60 degrees, and the 2500 newtons load is going to be acting at point C vertically downward direction that has given in the problem. And the tension T3 we have taken, that is in the string CD and making an angle of 60 degrees to the vertical, and with the vertical is going to be 60 degrees at point C as well as at D, we can see that point. So this way we are going to be draw the free body diagram, and then we are going to be using the sine or Lamis theorem or the resolution methods we are using to solve this problem. The second problem is that a uniform wheel of 60 centimeter diameter weighing 1000 newtons rests against a rectangular block 15 centimeters high lying on a horizontal plane. That means a wheel is going to be 60 centimeters. It is rested on the horizontal plane and it has a different parameters. It is to be pulled over this block by a horizontal force P applied to the end of a string wound around the circumference of the wheel. Find the force P when the wheel is just about to roll over the block. And this total text I am going to be showing here, the representing with the graphically. So first I have taken a horizontal plane where the wheel is going to be resting on this plane. So then I am going to be identifying the center of the wheel and the weight is going to be acting 1000 newtons vertically in the downward direction. Already he has mentioned the wheel diameter the 60 centimeters and the radius is going to be the 30 centimeters. So then in this case what happened, there is a rectangle block, that means it is going to be rested on the horizontal plane and the wheel also have a contact. So the wheel and the block contact I am going to be considered as the A, and the height of the rectangle block is going to be the 15 centimeters. So with this one we are trying to solve the problem, and the force P is going to be acting towards the right side, and that it is going to be, the string is going to be wounded around the wheel and is trying to pulling towards the right side. So then what will happen, it is going to be roll over the block. So we are going to be considering the free body diagram for that wheel. So what is our first conditions? We need to remove all the supports, horizontal plane as well as the rectangle block. In this case what happened, that ball is going to be trying to roll over that. So then we need to consider the reaction forces here. The first I have taken the wheel and then center I have considered, and the weight is going to be acting vertically downward direction. At the same time I have taken the line of action. So then what will happen, by using the transmissibility of the force, so we can shift this W either the above or the below of the point. So then what will happen here, the applied force is going to be acting towards the right side at the top of the wheel. So then what will happen, when you are extending this W as well as the P, that intersecting point is there. So that is going to be valid here. So here the contact point is going to be A. So that I projected on the line of action or the center of the wheel. So that intersecting point is going to be the D. That height is going to be, we are considering as the H. And similarly the point is going to be joining the point A as well as the C. So then what will happen? So then the height R is going to be R minus H. So that is going to be the radial distance. The next one I am going to be draw one more point, that's going to be where the point P and the W is going to be intersecting. So that point I am going to be considered as the E, and then height from the center to this is called the radial distance is the R. So then it is clear that where the reaction force is going to be generating, it is not in the AD or AC, but it is existed in the AE directions. That's because the weight is going to be moving, that line of action is vertically we have taken, and the P is going to be acting in the horizontal direction, that is the line of action. That intersecting point is the E. Then your reaction force is going to be developing in that directions where these 3 points, these 3 forces are going to be intersecting at point E. Then we can say these are the concurrent forces and coplanar forces. Then the body is going to be said to be in the equilibrium condition. So the wheel is just about to roll over the block, that means horizontal plane. So that it is going to be detaching from the ground. So there is no reaction force from the B. This way we are going to be draw the free body diagram. And here is the another problem. These are the different variety of the problems we are going to be seeing. A smooth circular cylinder of weight W and radius R rest in a V-shaped groove whose sides are inclined at an angle alpha and beta to the horizontal as shown. Find the reactions RA, RB at the points of contact. The given alpha is equal to 25 degrees, beta is equal to 65 degrees and W is equal to 400 newtons. So then I am going to be draw the diagram for this one. The first I have taken a cylindrical circular cylinder. The weight is going to be W, and initially I have marked the center, and then the weight is acting vertically downward direction, and then in this case that inclined plane it is going to be making with the horizontal alpha as well as the beta. So then it is going to be the horizontal plane and making an angle alpha, and similarly other side also have a contact with the B. So that's going to be making an angle of beta. These are the two planes A as well as the B, which are making an angle of alpha as well as the beta. So then what I'm going to do, I'm trying to take it here, the reference points here, that's going to be your the line which is perpendicular to the point of contact to the A from the center. And similarly for the point B also I have taken. So these are the reference points we do have taken. We are assuming that these two forces RA and RB is trying to pass through and they are going to be intersecting at point C. So here the free body diagram I am going to be try to draw. So first we have taken the cylinder and we are removing the supports A as well as the B, and when we remove it the body is trying to move in the specific direction. So then I am applying the reaction forces. Is W is acting, and similarly this is the line of actions already we have taken. This is going to be always perpendicular to the frictionless contact to the horizontal plane or the inclined plane. This is the line which is representing the reaction forces which is going to be acting towards the point C. So then this is the RA, and similarly there is another, the line of action we do have taken, which is always, this is going to be perpendicular to the point of contact between the circular cylinder and the B. So then the reaction force is going to be making RB and making an angle of beta, and the angle between the W and RA is the alpha, the W and RB is going to be the beta. That's already we have seen. This way we are going to be draw the free body diagram. And then what I am going to do, I am going to be taking the vector diagrams, the W, RA and RB. In this case few unknowns are available, RA and RB. To find this one by using the Lamis theorem, so then what will happen, the length of the force, here is the W, I am going to be taking the linear scale. So then I am going to draw the reaction forces here RA with an angle of alpha. And similarly I am going to be draw the RB which is acting towards the left side in the upward direction, that's making with the vertical plane is with the beta. And the RA and RB, the inclination is going to be 180 minus alpha plus beta, we have to take it. So what is the outcome from this one? The free body diagram we have drawn, we have practiced, and we are identified what are the external forces and internal forces, and practicing of the free body diagram for the different engineering problems we are doing. So thank you.